Hi, I am Dheeraj Chawda from second year Aeronautical Engineering. Today my topic for discussion is Poisson's ratio. Poisson's ratio was first given by a famous French mathematician Denis Poisson. So what is Poisson's ratio? Poisson's ratio basically gives us understanding how different material deforms under loading. Now let us understand Poisson's ratio in detail. Poisson's ratio is a ratio of lateral contraction strain to a longitudinal strain in the direction of the force applied. In simple words, it tells us how much it will contract in the lateral direction when the force is applied in the longitudinal direction or when the load is applied in the longitudinal direction. To calculate Poisson's ratio, we have a formula. Poisson's ratio is denoted by a Greek letter nu. So the formula for Poisson's ratio is nu is equals to minus lateral strain divided by longitudinal strain. Now you may be wondering, why are we using a negative sign? When there is a longitudinal strain or a longitudinal load is applied, there is a lateral contraction. Due to that contraction, it gives a negative sign. Now we want the Poisson's ratio to be positive, to have a positive value. So for that, we are multiplying it by a negative sign. The same case goes for when there is a longitudinal compression and a lateral expansion. Now let us understand Poisson's ratio with an amazing example of a rubber band. When a rubber band is pulled in a longitudinal direction, there is a lateral compression in the middle, or when it is compressed, it will expand in the lateral direction. The typically Poisson's ratio varies or have a value from -1 to 0.5. Most of the material that we see in our everyday life have a Poisson's ratio from 0 to 0.5. But here we have an amazing material which have a Poisson's ratio of 0. So that material is none other than cork. How the value of Poisson's ratio is 0? When there is a strain or a load applied in the longitudinal direction, there is no lateral contraction in that cork or the material of the cork. So this is the amazing property of cork. Now the concept in Poisson's ratio only applicable to isotropic material. What is isotropic material? Isotropic material means all the materials or the property of the materials are same in all directions. So the Poisson's ratio is only applicable to those. The Poisson's ratio should be deformed in the elastic limit or in the elastic region. If a material deforms into a plastic region or goes beyond the elastic region, the Poisson's ratio will continuously vary. So this was all about my topic. Thank you all for watching.